Section 12.2, exponential functions. Now what we're going to do with exponential functions is two different things. We're going to graph them to see what do exponential functions look like, and then we're going to solve some. All right, so what we'll do is this. First, an exponential function is simply a function with an exponent in it, and that exponent includes one of your variables. Okay, so in order to graph them, you've got to plot some points. All right, once you've started plotting some, then you can start recognizing the pattern and what that shape will look like. But what we'll do is let's plot some. So for the first graph here, I want to show you the difference between 2 to the x power and 4 to the x power, and so we'll graph both of those on this same graph. So what you'll need to do is you'll need to start with some negative x's and then move towards some positive ones. So I've started with -2, -1, 0, 1, 2, and 3 here. So 2 to the -2 power, remember a negative power flips it, and then 2 squared is 4, and it flips it and makes it 1/4. 2 to the -1 just flips it, and so that's just 1/2. 2 to the 0, anything to the 0 power, remember, is 1. 2 to the 1 power is just 2, and 2 squared is 4, and 2 to the 3rd power is 2 times 2 is 4 times another 2 is 8. And so when we plot those, we're going to plot, so these are our x's that I put in. All right, so -2, 1, 2, -2, 1/4 is right here. -1, 1/2 is right here. 0, 1 is right here. 1, 2 is right here. 2, 1, 2, 3, 4 is right here, and then 3, 4, 5, 6, 7, 8 is right here. So it looks like the smaller that gets, the closer it's going to get to 0, and the larger it gets, it's going to go up and get larger pretty quickly. All right, so let's do the 4 to the x power. Again, 4 squared is 16, and because it's a negative power, it's going to be 1/16. 4 to the -1 flips it and makes it 1/4. 4 to the 0, anything to the 0 is 1. 4 to the 1 is itself. 4 squared is 16, and that's a pretty big number, so let's stop there. So 4 to the -2, so -2 is our x, and 1/16 is little bitty. And then -1 is our x, and 1/4 is pretty little. And 0, 1, oh, check that out, that's in the same spot. And then 1, 4 is right here, and 2, 16 is like way up off of our graph. And so it looks like the same type of thing is going to happen to the left. It's going to start small, and then it's actually going to do the same type of thing, but it's going to get much bigger, much quicker. All right, and so now let's see what happens if we do this same thing. What happens if we take this 2x, 2 to the x power, and just add 1 to it? Okay, so 2 to the x power plus 1. Well, that's going to be these numbers, 2 to the x power plus 1 more. So if we add 1, we're going to have 1 and 1/4. If we add 1, 1 and 1/2. We add 1 to that, we get 2. Add 1 to that, we get 3. Add 1 to that, we get 5. And add 1 to that, we get 9. So now our new numbers are -2, 1 1/4 bumps it to about here. -1, 1 1/2 bumps it to here. 0 is 2 now, so it's right here. 1 is 3, 1, 2, 3 here. And then 2 is up to 5. 1, 2, 3, 4, 5 is up to here. And 2, what are we on? 1, 2, 3 is up to 9. So this was 1, 2, 3, 4, 5, 6, 7, 8, 9. So up here. So it looks to be, which is what it should be. So it's the same curve as this blue one. It's just bumped up 1. So if you have an exponent part, a base with an exponent, and then you're going to add something, this base with an exponent is going to be, it's going to start at the 0 baseline, and it's going to move up. Depending on what your base is, it's going to go up very quickly. All right? Now, if you add 1 or subtract 1, that's going to shift the whole graph either up or down. Okay? So if you've got an exponent +1 or -6, or then it would just shift it, and you would have the exact same graph. Now, what happens if we use fractions? Let's do that. What if we have a fraction for a base? Does that change it at all? Well, let's look and see. So with 1/2, let's start with 1/2. And what we're going to do is 1/2. Now remember, negative is going to flip it. So 2 squared is 4, and then flip it so it's 4, not 1/4, right? The negative power flips it, and then 2 to the 1 power is just 2. 1/2 to the 0 power, anything to the 0 power is 1. 1/2 to the 1 power is itself. And 1/2 squared, 2 times 2 is 4, so it's 1/4. So now we end up with -2, 4, 1, 2, 3, 4. So right here. And then -1, 2 is right here. And 0, 1 is right here. And 1, 1/2. And then 2 and 1/4 is here. And probably if we went -3, -3 is going to flip it and be 2 over 1. So 2 cubed, which would be 8. 1, 2, 3, 4, 5, 6, 7, 8 would be way up here. So if we have a fraction, we're going to have the same type of curve, only flipped. We're going to start large and we're going to go small very quickly. Because if you take a fraction and you multiply it by itself over and over and over and over and over again, it's going to get smaller and smaller and smaller instead of larger and larger, because the denominator actually gets larger, and that chops those pieces smaller and smaller. So the same thing happens with our 1/4. Let's do that real quick. The negative flips it, and then 4 squared is 16. Negative flips this, and 4 to the 1 is 4. Anything to the 0 is 1. Anything to the 1 is itself. And 4 squared is 16, so it's 1 over 16. So we have -2. 16 is somewhere way off the charts for us. -1, 1, 2, 3, 4. 0, 1 is the same crossing point. 1, 1/4, and this gets small very quickly. So you can see it's the same as this green graph, only flipped. All right? Now, so that's graphing them. And really and truly, just graph -2, -1, 0, 1, and 2. And you'll be able to see the general form of the graph. All right. So the only other thing we're going to do today is I would like for you to be able to solve exponential functions. So here we have a function, 3 to the x power equals 81. Well, how on earth are we going to find out what that exponent is? Well, if you find out what the base, if you can put this side of the equation into the form of the same base to a power, then the powers have to be equal to each other, right? So 3 to the x power equals 3 to some power. Well, 81 is 3 to the 4th power. 3 times 3 is 9, and 9 times 9 is 81, so that's 4 factors of 3. So 3 to the 4th power is 81. So 3 to the x power equals 3 to the 4th power. Well, can you see that x must be equal to 4 because the bases are the same? So if these are equivalent values and the bases are the same, then the exponents must also be the same. All right? So what happens, though, if you can't put that other number into the same base? Because 4 times 4 is 16, and 16 times 4 is 64. And that's not going to work. But I know that 32 is 2 to the 5th power, right? 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. 16 times 2 is 32. So that's 5. Well, what happens if we do this? We can say that 4 is 2 squared, right? And so we still have to keep that x. So what you have here is 2 squared to the x power, right? 4 is 2 squared, and we want 4 to the x power. And remember, if you take a power to a power, you just multiply the powers. So let's make this neater and larger so you can see it. So we have 2 to the 2x power. All right, so what you can do is break down the base into its factors and then raise it to a power. Now, because the bases are the same, you can set your exponents equal to each other. So 2x equals 5. And so now to find out what x equals, just divide by 2. So x equals 5 over 2. And you're finished. Remember, in algebra, we can leave them in proper fractions, and that's fine. All right, easy enough? Okay, of course I'm going to make it a little more difficult. Here we go. So what if we have 5 to the x power, and that's equal to 1 over 25? Well, how can I make 1 over 25 have a 5 as a base? Well, you know that 1 over 25, you know that 25 is 5 squared, right? So that equals 5 squared, but it's under the denominator. It's in the denominator. Do you remember that in order to flip that fraction, all you do is give that exponent a negative, make the exponent negative. So 5 to the x power is going to equal 5 to the negative 2 power. All right? Because the negative power flips the fraction. All right? So it's 5 to the negative 2. So now x equals negative 2. Ta-da! Easy. It might also be easier if you change this 1 over 25, change it first to 25 to the negative 1 power, and then break it down. So either direction will give you the same answer. So this is 5 to the negative 2. It's going to be the same answer, whichever direction you do it. Okay? All right, one more. And you can see a fraction. Anytime you've got a fraction in your equation there, you know you're going to end up with a negative exponent somewhere. All right, so in this case, 1/3 to the x power equals 27. We can change this 1/3 to 3 to the negative x power, because this is 3 to the negative 1. 1/3 is 3 to the negative 1, and negative 1 times x is just negative x. So 3 to the negative x power equals, well, 27. Can you take 3 to a power and get 27? 3 times 3 is 9, and 9 times 3 is 27. So to the 3rd power. So now when you set your exponents, so your base is 3, your exponents must be equal to each other. So negative x equals 3. And so how do you get that x by itself? It's negative, so divide by negative 1. So now x equals negative 3. Because 3 divided by negative 1 is negative 3. All right? So, yes, so just put in x's and get out y's for graphing. And anything that has a whole number as a base should start very small and get larger quickly. Anything with a fraction base should start large and get small very quickly. All right, and then solving with exponential functions, you're going to, the name of the game is get the bases the same. Once the base is the same, just set the exponents equal to each other and solve it. That's it. See you next time.